Video solutions for Unit 1, two-dimensional geometry homework packet 82 through 91. So we're working on a sequence of transformations. So for each problem, determine if the two figures are congruent, similar, neither, and then explain how one figure was derived or creates the other. Right off the bat, I can see they're not congruent because they're not exactly the same. But I need to see if they are similar. Similar means exactly the same shape but different size. So they have to be proportional. So what we're going to do every time is we're going to just do a simple proportion where I'm going to match up sides of the original one with the corresponding side of the new shape. Then I'm going to do that with two other sides and see if I have a proportion. If I do, then they're similar, and I'll even have my scale factor. So here this distance is 1, 2, 3, and this distance is 1, 2. So just like our scale factor from last week, we want to put the new number on the top, the old one on the bottom. So the new shape is right here. It has that prime symbol. So that's 2, and the old one is 3. Okay, now let's do the same thing down here. So 1, 2, 3. So that's the old going to the new, 1, 2. And you can see that 2/3 does in fact equal 2/3. So we know this was a dilation. And we know the scale factor was equal to 2/3. This shape is 2/3 of that. Now we need to see how we get from here to here. So we already know we dilated it, so we made it smaller. So let's always start with rotations. They're kind of easy to see. It's not a rotation because if I had started a rotation here, either clockwise or counterclockwise, I would have had the full figure in one quadrant. You can see it's in two quadrants right here. So that's not a rotation. I know it's not a reflection because a characteristic of a reflection is, here's A. If I reflected that, A would have come over and been on this side right here. So I know it's not a reflection. So let's look and see if it's a translation. All right? So I'm going from this point right here across, and then I'm going down to there. So it looks like our translation would be x plus, and I'm going over 8, and then y minus, I'm going down 4. So we have a dilation with the scale factor 2/3, and then we had a translation of x plus 8 and y minus 4. Okay. Well, they look congruent, but we have to check. So let's go ahead and make our proportion. So let's use this side right here and then match it with that side. So we're 1, 2, 3. That's the old one. 1, 2, 3. That's the new one. And now we have to do it with another one. So 1, 2, 3, 4, 5 with the old one. And 1, 2, 3, 4, 5 with the new one. Okay, if we simplify those, 3 over 3 is 1. 5 over 5 is 1. So they are exactly the same. Now, yes, this is a proportion. That's true. But in this case, it's not a dilation because our scale factor would be 1. And of course, if it's times by 1, it's the exact same shape. So we know it is congruent, though. Okay. Well, it looks like it could be a rotation, except for if I were to measure this distance right here to this point and here to this point, I know that they're not the same, and they have to be. Another way to do that is if I go, let's say, to that point right there and to its corresponding point here, notice that from one quadrant to there, it should be 90 degrees, but look at that angle. That's more than 90. So we know it's not a rotation. Okay, let's see if it's a reflection. Well, it has the attributes. A comes over here, and then it flips over to this. So it looks like I'm going to have to flip it, and then it looks like I drop it down. So let's see what our line of reflection is. So let's count from this point over to that point, because that's where this point right here would be. So 1, 2, 3, 4. Cut 4 in half, I get 2. So 1, 2. So it looks like my line of reflection would be right here, which is the x-axis. So then this shape right here would flip across it. So I'd have a point there. And then if I count 1, 2, 3, 4, 5, 6, 7, so then 7 on this side. 1, 2, 3, 4, 5, 6, 7. So I'd be right there. And if I do the same thing here, I have 7. And I count over here, I have 7. So what we have is there's our reflected shape. A would be up here. But then I need to get it down there. So what would I do? Well, let's write first. Okay, so we have a reflection across. So what is this line of reflection? That's the y-axis. And then we're going to do a translation. Well, I don't go left or right, so I'm going from here to here. So x stays the same, but y has to go down 1, 2, 3. So I'm subtracting 3. So they're congruent. Then I reflect across the y-axis, and then I bring it down to there. All right. Well, I'm going from this shape to this shape. So they certainly look congruent, but let's just measure. So I basically have my proportion. So I have this shape here and that shape there. It looks like, okay, old is 2 and the new is 2. Now let's look at the side. 1, 2, 3, 4, 5. The old is 5. 1, 2, 3, 4, 5. The new is 5. And we have a problem like we just had in 83. So that's a 1-to-1 ratio, so it means it's exactly the same. Okay, notice that our A and our A are in the same orientation, which means they're in the same spot in the figure, so we're not reflecting. And doesn't look like I'm rotating because this whole figure is in quadrant 1, but this one is in 2 quadrants. So it looks like it's just going to be a translation. So they're congruent. All right, but I got to get from here across, remember always left to right first, and then down to there. So if you were to mark like I do, it would make it easier. All right, so it looks like my x, I'm going to go left, so I'm subtracting. And how far? 1, 2, 3, 4, 5, 6, 7, 8. I'm subtracting 8. And then what am I doing with my y? I'm going down 2, 3, 4, 5, so that's minus 5. Okay, so that really isn't the sequence of transformations there. All right, 85. Okay, it looks again like they're congruent, but let's just double check. So we have our proportion. So I'm going from A to A prime, so let's start with here. This one looks like it's 2, so that's the old. And this one is 2, that's the new. Okay, let's do this bottom. 1, 2, 3, 4, that's the old. 1, 2, 3, 4, that's the new. So again, we have a 1-to-1 relationship, so we know they're congruent. All right, so we start with rotations. It looks like I'm rotating. I have the shape all in this quadrant and then all in this quadrant. It looks like it's turned. So let's just double check. Here's A. So I'm going to that A. So it looks like that is what point? That's over 5 and up 6. So if I were to rotate it 90 degrees counterclockwise, we know that these two numbers would switch, and I would be in this quadrant, so it would be a negative and a positive. So let's see if that's true. Negative 6, positive 5, and it is. So I know I did a 90-degree rotation counterclockwise. And I didn't have to do anything else. 86. All right. Okay, so here we have our original shape A and our new shape here. Now they don't look alike. All right, so they're obviously not congruent, but they could be similar. So I have to see if they're proportional. So let's do this side right here. So it's 1, 2, 3, 4. That's the old. This side, I can't tell if that's 1, 2, maybe 2.5. So let's actually write that up here. Okay. Now let's go this side. I know that's 8, so that's the old. And I know this is 1. Okay, so that certainly doesn't match. But I'm assuming that I'm just making a dilation. What if I'm actually rotating this? So we might have a different type of proportion. So let's try it the other way. Okay? So instead, this is the long side here, and I have the long side there. Okay, so we can see what that is. So this I have 1, 2, 3, 4. That's the old, but that's the short side. So I have to go over here and do the short side right there. I should have thought of that first. So that's only 1. Okay, now let's do the long side. Well, we know this right here is 8. So that's the old. And we know this looks like, I guess it's 2. It's just off a little bit. All right, so does 1/4 equal 2/8? One way to check if it's proportional is to cross multiply. 1 times 8 is 8. 2 times 4 is 8. 8 equals 8. So yes, it's a dilation. And we know that it's a scale of 1/4. 2/8 is 1/4, so I always use the simplified. And then what did I do to get this over here? Maybe a rotation, huh? Okay, I certainly I could have reflected it a little bit, all right, because that goes to that side. But let's see if it's a rotation first. So here I am. Here's my 2 A's. So here I started at 8, 4. So if I rotated it 90 degrees that way, this would become a 4, and that would become an 8, and it would be -4, +8. Okay? So does it look like I just did that? Although it could have been, I guess, a dilation. So here, so that would put it over -4, +8 right here. And then if we do that side, that was 8, 0. So this would be 0, 8. So there, so our new shape would look something like this. So it looks like what we did first is we did our rotation. Okay, so this A here would have popped up over here. So they're still there. And then I dilated it. Okay, so I had a -4/8. And if I go ahead and take my scale factor of 1/4, remember how we see what the new points are? 1/4 of -4 would be -4/4, which is -1. And then 1/4 of 8 would be 8/4, or 2. So my new point on this is -1, +2, and there it is. So what I did is I did the rotation first, 90 degrees rotation, counterclockwise. So I got it to there, and then I shrunk it down to there. Okay, a little harder one. All right, 87. Well, it looks like they're about the same, but let's check. So I know I'm going to check this side here, and it looks like that side there. So this is 1, 2, 3, and that's the old. 1, 2, 3, that's the new. And let's just check this. That's 5. That's the old. Here's the new. Yep, so we have a 1-to-1 relationship, so we know they're congruent. So how did I get there? Well, I know it can't be a rotation because this shape it's all in quadrant 2. This shape here is almost in 3 quadrants. Okay, so it looks like maybe I did maybe a translation over here, so the A will match up over here, and then a flip. Okay, so let's move this right here over to there. So if I did that, the Y or the X is going to the right, 1, 2, 3, 4, and the Y is not going up or down at all. So now my new shape is is right here. So that's what my new shape looks like. I just slid it over 4 to the right. Okay, now it looks like this point here, A, is lined up with that. Oh no, I went a little too far, sorry. So let's go back. My eyes deceive me here. So I'm only going this far, right there. Now the A's match up above and below. So what am I doing there? I'm going x plus 1, 2, 3, and then the y isn't staying, or is staying put. Okay, so now my shape is right here. Okay? Oh, a little bit too, that's over. There we go. A little hard to see up there. All right, so there's my shape now, and then it looks like I reflected. So what's the difference between this A and that A? 1, 2, 3, 4, so cut it in half. So my line of reflection would go that way. So we know that it's crossing the y-axis at 3. So my line of reflection is y equals 3. So I did a slide, then I did a flip. Okay. Let's see if this is congruent or similar. Well, let's just check the bottom. So let's check this. That looks like it's 5. Check this. That's 5. Let's check the height. Basically, that was about 2 right there, and that looks like it's about 2 right there. So they certainly look congruent. Now, rotation. It does look like I rotated this that direction. So let's double check. Or actually, I'm sorry, it wouldn't be that way. It would be this way, huh? That way, because there's my A, and here's my A prime. So that A is -8, +1. So if I rotated 90 degrees, okay, 90 degrees, then I'm going to switch these numbers. So that would become 1, 8, and they'd be positive. Okay, well, you might be saying, well, that's not it, because look at that A is over 3 and up 6. But what if I rotated and then slid it? So I would have 1, 8, and then what would this point be? Okay, that point would be 1, 2, 3, 4, 5 down from the top. 2, 3, 4, 5. So that would be there. And then this shape would have a little kind of circle on it like this. Okay, now I have to get it from there's my A. See how it rotated to there? And I got to get it to there. Well, don't I just slide it over and then slide it down? So it looks like I did a 90-degree rotation clockwise. And then I did a translation. So I went over 1, 2, so x plus 2. And then I went down to y minus 2. Right? So this, makes it kind of confusing sometimes. So you actually got to try. You just can't look at it and get the answer. I can't even. Okay, let's do another one. Okay, well, they're certainly not congruent. Let's see if they're similar. So we have to do our proportion. So let's go this distance right here. That's 1, 2, 3, 4, 5. That's the old. And so that would be this distance right here. It looks like it's 2.5. Okay, now let's do this side here. So that's 5. That's the old. And this side right here looks like it's 2.5. So certainly they're equal. Now, if I want to figure out my scale factor, 2.5 over 5, that's actually going to be 1/2. So this shape is half of that. So I do know it's a dilation, and the scale factor is 1/2. Now, how do we do this? Well, it looks like I have the A on the left part of the shape and then the A on the right. So it looks like maybe I do a reflection first. Then that A right here would bring it to about there, and then I maybe shrink it. So let's double check. So let's find our line of reflection. Well, I'm 1 away here. I'm 2 away there from that point. So I'd have to be 1.5. Okay? So my line of reflection would be somewhere right here in the middle. Okay, I'm not sure if I'm correct yet, so I'll just put it's crossing the x-axis at -1/2. Okay, so that's going to bring this over to here, 1.5, so that's going to be there. And then this is 5, so 1, 2, 3, 4, 5. And then that would be over to here. So that shape would look like this. So I flipped it. So there's your A. Now I have to get it over to there with the dilation. So see if the dilation did that. So this point is 6, -3. So if I took half of that, remember how we take our scale factor? So half of 6 and half of the -3. So this would be 6/2 or 3. And this would be -3/2 or -1.5. So let me see. Over, no, that's over 3.5 and down 1.5. So I'm not sure on that. We'll have to talk about that in class. I don't want to take any more time. So I'll figure it out and then come back to you guys. Okay. All right, let's do one more. So it looks like I'm going from A here to A prime. They certainly aren't congruent because they're different sizes. So let's see if they're dilations. Remember, they have to be proportional. So instead of measuring these hypotenuses, all right, that are going at an angle, let's measure down like that and across, down like that and across. So this is our old, so that's 2. This is our new, that's 4. Okay, this is our old, that's 2 going across. This is our new, that's 4 going across. So you can see that they're equal, so they are proportional. And to find the scale factor, well, 4/2 is actually 2/1 or 2. So we know that it's a dilation with a scale factor of 2. This is twice as big. Now, how did we get there? Well, it looks like, let me see, I'm going from this point over to here, no, right there, and then this point down. So, what am I doing with my x? I'm going to the left, 4, and then another 4, so that's 8. So I went 8 to the left. Looks like I'm going down 1, 2, 3, 4, 5, 6. So y -6. So it's a dilation and then it's a translation. So you can do 91 on your own, and we'll talk a little bit more about 89 as well.